Hi, my name is Sarah Halsey, and I am presenting my honors thesis in mathematics. The title is Predicting Mental Health Outcomes of Meredith College Students. I started my career at Meredith College as a student athlete. Having been diagnosed with severe anxiety and depression in early high school, athletics were sometimes a source of mental health struggles. As I entered college playing soccer and saw other student athletes have intense struggles, I knew I wasn't the only one. We've also seen an increase in celebrity athletes coming forward with their mental health struggles as well. Athletes like Simone Biles and Michael Phelps have been open about mental health and how sports affects that. To hone in on one mental illness, anxiety is the most common mental health illness affecting 40 million US adults. Furthermore, anxiety is the most common mental health illness among college students, affecting 42%. I knew Meredith College was no different. I knew that I wasn't the only one who suffered from anxiety. I set out to discover which Meredith College students are at high risk for anxiety based on various factors using logistic regression techniques. In order to create a logistic model, I needed data. To get data, I created a survey. First, I had to get approval of this survey in order to send it to all Meredith College students. Meredith's Institutional Review Board, the IRB, is in place at Meredith College to provide protections for research participants when research projects involve humans. After filling out various forms, creating a consent form for participants, and my advisor and I completing a data safety class, my survey was approved by the IRB. The survey had 3 parts. The first part of the survey was the consent form approved by the IRB. This explained why I was doing the research. Furthermore, participants were asked to consent officially. The second part of the survey was for all students, regardless of athletic status. Participants were asked to answer a variety of questions, such as class year, GPA, and major. Finally, they were asked to rate different anxiety symptoms per the Beck Anxiety Inventory, and they were asked to reflect on this past school year and rate symptoms on a scale of 0 to 3. 0 having not experienced that particular system, and 3 being severely experiencing that system. The third part was for athletes only. Here, they were asked different questions about their athletic identity. Questions included sport played, frequency of participation, years playing collegiate sport, and concussions occurring. Distributing it amongst all of Meredith College was simple, as I contacted each class year's president and asked them to circulate the survey around their class by email. The Beck Anxiety Inventory consists of 21 self-reported items, 4-point scale from 0 to 3, like mentioned before. It is used to assess the intensity of physical and cognitive anxiety symptoms, and this is what I used to measure the participants' anxiety. An integral part of this research, and any research involving data, is data wrangling. Data wrangling is the process of cleaning data sets in order for model making and analysis to be easier. When I downloaded my responses to this survey, my data set was messy. Variable names were long, which made it difficult to create a model. So below is an example of renaming variables to shorter ones. I also needed to categorize different variables. For example, there were a wide range of GPAs. As seen in the second picture of code, I categorized these for easier analysis by making a new variable which grouped individual GPAs into groups. I also made a new variable that summed all of the individual anxiety symptom scores. So each participant had a total anxiety score. This would then help me make it into a binary variable as seen in the third picture of the code. This looks a little confusing, so I will be going into more detail when looking at visualizations. After cleaning up the data set, I ended up with 41 total variables. To determine which variables to initially include in my logistic regression model, I performed exploratory data analysis and created some visualizations. These visualizations helped me determine which variables were associated with the anxiety score. Our first visualization shows the distribution of total anxiety score broken down by academic department. The 2 dashed lines represent thresholds that the Beck Anxiety Inventory designates as moderate anxiety, represented by the orange line, and severe anxiety, represented by the red line. As we can see, 3 out of the 4 academic departments have 50% of observations having at least moderate anxiety. This is shown as the thick black line in the middle of each box. Furthermore, in business and natural and mathematical sciences, at least 25% of respondents have severe anxiety, which we can see at the top of the box. We can definitely see that certain departments have higher anxiety scores. The first thing I want to explain about this visualization is the y-axis, which is the vertical line on the very left. This is when I made a new variable that was binary, which distinguished anxiety prevalence. Going back to the 2 dashed lines that indicated moderate or severe anxiety, I used the anxiety total variable to create 2 possibilities. If a participant had a score of less than 22, this indicated very low anxiety, resulting in a 0. If a participant had a score of greater than 22, this indicated either moderate or severe anxiety, resulting in a 1. Coding the anxiety score in this way is necessary in order to fit a logistic regression model that can be used to predict the probability a student has anxiety. The graph on the top shows the distribution of GPA for students who have moderate to severe anxiety symptoms, and the graph on the bottom shows the distribution of GPA for students who have low or no anxiety symptoms. These two distributions are pretty similar, but there does appear to be more students with moderate to high anxiety symptoms who also have lower GPAs. This indicates that there's possibly an association between GPA and anxiety prevalence. This visual gives us a different way of looking at the association between GPA and anxiety prevalence. However, now we're looking at GPA categories. We can see that students with lower GPAs are actually at higher risk for anxiety. This is the opposite from what I was expecting prior to starting this research. And this visual proposes that students with lower GPAs may be more likely to experience anxiety. When I first began this research, I thought a participant who was an athlete would have a higher anxiety score compared to a participant who was not an athlete. However, looking at this visualization, we can see a different outcome. This visual shows the prevalence of anxiety based on athlete status. So we can see that in both categories, athlete or not, almost 50% of observations had either moderate or severe anxiety. This visual follows the same format as the previous. Again, we're looking at anxiety prevalence. However, this is grouped by academic department. We can see in 3 out of the 4 academic departments, 50% of participants experience moderate or severe anxiety. This is important as it shows an association between those two variables. If a student is majoring in a particular department, then they might be at higher risk for anxiety. This shows anxiety prevalence based on class year. We can see that participants in their freshman and junior year have a higher prevalence of anxiety compared to sophomores and seniors. We might expect this as it is common belief that junior year is the most stressful and challenging year in college. In addition, freshman year is always a difficult adjustment for students coming out of high school. This also indicates that students in certain years will be at higher risk for anxiety. In my research, the response variable I'm interested in, anxiety prevalence, is a categorical variable with only 2 categories, which can be thought of as success and failure. In my research, a success is anxiety and a failure is no anxiety. Predicting a categorical response is often referred to as classification, since it involves assigning an observation to one of the 2 categories. The goal of my research is to classify a student as having anxiety or no anxiety, based on factors such as GPA, year in school, athletic status, and academic department. Logistic regression is one method of classification, and it uses predictor variables to first model the probability of success. We can't use a linear model for this probability, since the probability must be between 0 and 1, but we can transform the response first to make sure it has the appropriate range. After we fit the model using data, we can untransform a predicted value and get that probability of success for the observation. We finally compare the predicted probability to a threshold value to determine which category the observation should be. In my case, anxiety or no anxiety. Note that not every variable group is seen in this model. The ones missing, labeled baselines below, are used for comparison. For example, if we have a student in the natural and mathematical sciences department with all else held constant, that student would have an increase of experiencing anxiety compared to a student in the arts and humanities department. Note that the positive coefficients in front of each group indicates an increase in probability for anxiety. Contrary, negative coefficients indicates a decrease in probability for anxiety. To further understand what the model does, let's look at an example student. Meet student A. Student A has a GPA of 2.8, placing the student in the 2.6 to 3.0 GPA group. Student A is also majoring in business, putting them in the business department, and they are not an athlete, but they are a junior. So is student A at high risk for high anxiety? According to my model, yes. The probability that the student A is at high risk for anxiety is 0.9243. Using the threshold of 0.3, this would place student A in the category of having anxiety. An important way to evaluate how well our model predicts the probability a student is at high risk for anxiety is to use a confusion matrix. Here's a skeleton of what a confusion matrix looks like. In this research, a true positive indicates that the model correctly identified a student who is at high risk for anxiety. A true negative correlates to the model correctly predicting a student who did not have anxiety. The 2 boxes we want to avoid are false positives and false negatives. False positives indicate that the model mispredicted someone at high risk for anxiety when they actually don't. Not too big of a deal. False negatives would be more dangerous than false positives. These are representative of the model misclassifying someone who does not have anxiety who really does. This is the one we want to avoid the most because that student would not be able to get the help and resources that they need. I created two confusion matrices. After splitting my data into training data, which I used to create my model, and testing data, which I used to test the accuracy of my model, I computed two confusion matrices. This visual shows the confusion matrix for the training data. We expect the results to be better using this data since we used the training data to fit a model. Here we can see that we were successful in keeping the false negatives to a minimum with about 4. This means our model incorrectly identified 4 students as not having a high risk for anxiety when they really do. We can also see that we misidentified 34 students as having anxiety who really don't. This isn't great, but it's better than having an increase in false negatives. Here we can see the confusion matrix for the testing data, which is used to test the accuracy of our model. This proved to be successful as well, as we kept the false negatives to a minimum once again with only 2. This means our model incorrectly categorized 2 observations as not having anxiety when they do. Again, we have 11 false positives, which means the model incorrectly classified someone as having anxiety when they don't. But in this instance, we would rather have a higher number of false positives than false negatives. While I've already done a plethora of work already, I have more I would like to investigate. As this model just predicted whether a student at Meredith College is at high risk for anxiety, I'd like to hone in on athletes. Looking at visualizations, we can see that there are many athletes who experience moderate to severe anxiety. Note in the first picture, basketball, golf, volleyball, and tennis are not included as there were not enough observations. Furthermore, those athletes who played on a team sport denoted 1, such as basketball, field hockey, lacrosse, softball, soccer, and volleyball, have a higher prevalence of anxiety. Those participating in an individual sport denoted 0, such as golf, tennis, track and field, and cross country, have less prevalence of anxiety. I look forward to doing more analysis with the athletes. I'm confident that my research and model will be of value for not only Meredith College students, but college students as a whole, as we can detect students who are at high risk for anxiety. I'd also like to acknowledge and thank Dr. Andrea McPherson from the Psychology Department, Dr. Janie McMillan, the Director of the Institutional Review Board, and my advisor, Dr. Emily Latta, for my help with my research. Thank you.